A great deal of recent scrutiny. Clinicians are raising questions about the effects of working in environments that are too bright, too dark, or inconsistently lit. Others are concerned that the recent trend to replace traditional incandescent bulbs with energy-efficient LED and fluorescent lights may be increasing the risk of eye strain and related symptoms. While new lighting can significantly reduce energy costs, its long-term visual effects have prompted some to explore ways to limit worker exposure to this type of illumination. Beyond health issues, researchers have studied the psychological impact of different lighting levels. Findings indicate bright lights tend to make employees feel more alert, which helps them concentrate on the task at hand. Conversely, dimming the lights can make people more creative, especially useful for brainstorming sessions. Therefore, adjusting illumination to the level appropriate for the activity may, at least in theory, promote worker performance. This video is a quick review of some measures you can take to help minimize the effects of poor quality lighting. Along the way, we briefly discussed AEMC light meters that enable you to monitor illumination in your facility to ensure your employees are provided with a well-lit and healthy environment. When discussing lighting, it's important to understand the distinction between the terms illuminance, luminous flux, and luminous intensity. Luminous flux is the total amount of energy emitted from a light source in all directions. Luminous flux is measured in units called lumens. Luminous intensity is the amount of light emitted by a light source in a specific direction. This is measured in candelas. Illuminance is the amount of incident light spread over a given area. This is measured in lux, equal to 1 lumen per square meter, or foot candles, 1 lumen per square foot. To help visualize the relationship between these terms, it may be useful to compare a light source to a lawn sprinkler that sprays water in all directions. Luminous flux is analogous to the total amount of water the sprinkler sprays. Luminous intensity corresponds to the amount of water that flows out of a single hole in the sprinkler head. And illuminance is the amount of water that falls on a given area of the lawn. The U.S. Department of Labor's OSHA standard calls for minimum illumination levels for a number of different venues, including general construction areas, indoor warehouses, tunnels and other underground work areas, workrooms, first aid stations, offices, and others. In addition to these minimum levels, it can be equally important to be mindful of the appropriate maximum illumination for environments such as workplaces, a topic we'll address shortly. Although research is still ongoing, evidence appears to be mounting about the potential health risks associated with LED and fluorescent lighting. For example, medical researchers have found that prolonged exposure to LED lights may cause irreparable damage to the retinas of the human eye. LEDs typically produce light in the high-energy blue and violet end of the visible light spectrum. Light from this spectral region can be particularly damaging to structures within the eye. In addition, LEDs do not produce near-infrared radiation, which many medical professionals believe is necessary for overall health. Fluorescent lighting has also been studied for its potential detrimental health effects. For instance, some fluorescent lights emit high levels of ultraviolet radiation, which has been cited as potentially damaging to vision. One study estimates that fluorescent lighting may increase UV-related eye diseases by up to 12%. And as with LEDs, fluorescent lights produce a rather limited spectrum. As a result of these and other potential health issues, many are paying special attention to the levels of LED and fluorescent lighting in their facilities. The typical office environment where employees spend hours on computers presents special lighting challenges. The average office illumination ranges between 75 and 150 foot candles. This is significantly higher than the recommended levels for working with computers. For instance, the suggested illumination for working with a computer display with a dark background is 18 to 46 foot candles, while the recommendation for displays with white backgrounds is 50 to 75 foot candles. When the room is too bright for the computer, users often experience visual discomfort and related symptoms. Perhaps even more important than brightness level is intensity evenness. In other words, maintaining an environment in which all objects in your field of view are more or less of equal brightness. Bright LEDs can often illuminate objects unevenly, causing high contrast images that can produce eye strain. There are a number of measures you can take to help maintain illumination at an appropriate and consistent level. For example, you can use smaller desk lamps with incandescent bulbs rather than bright overhead lights. If you install auxiliary desk lighting, use low wattage and aim the light in a direction that does not directly enter your eyes or illuminate the computer display screen. Add blinds or drapes on windows. Adjust these throughout the day to admit the appropriate level of light. Orient workstations to avoid direct viewing of bright lights while minimizing screen glare and reflections. Avoid white reflective surfaces in favor of matte desktops, furnishings, ceilings, and walls. If bright overhead lights cannot be dimmed or eliminated, advise employees to wear a visor to shield their eyes. When working with a computer, adjust the screen brightness and contrast to maximize character definition and resolution. Brightness should match the general background level of the room. If the screen appears to flicker, turn down its brightness level. Finally, advise your employees to take regular breaks from their computers and mobile screens. Some clinicians suggest 20-20-20 breaks. Every 20 minutes, take 20 seconds and look 20 feet away. To help measure and monitor light in your facility, AEMC offers portable, easy-to-use light meters that incorporate optical sensors designed to match the response of the human eye. This makes them ideal for workplace analysis and planning. Each instrument features one-hand operation with an ergonomically designed case, large 3.5-digit backlit LCD display, and intuitive function selection including hold and max. Other features are model-dependent, including peak, map, and data logging. Note that the light meter data logger Model 1110 can perform a variety of recording tasks with easy and intuitive setup from a computer using AEMC's DataView software, provided free with the instrument in the Americas and Australia. The Model 1110 also includes a map feature. This lets you plot the illumination for a two-dimensional space or surface. For example, in map mode, you can measure the illumination at specific points within a room. You can then download the recording to a computer running DataView and display the measurement as a two-dimensional matrix, creating a map of the illumination within the room. This helps you quickly identify areas of dark, overly bright, and uneven lighting as indicated by the shading in the blocks. Hovering the cursor over one of the blocks will display the actual measurement. The Model 1110 can also be set up to measure specific types of lighting sources, including LED and fluorescent.